Hey, how's it going? And today we're taking a look at parametric types. I'm doing this because I found this to be an advanced and challenging topic, and I wanted to put it into my own words. So, in the documentation, it says that parametric types refer to any type that can take a parameter. I found that definition to be a little bit of circular logic. It's using its own words as the definition. And then down here on this example, they give an example down here and it says here hello and 0.0 are explicit arguments, but there is no hello and it just says T there. So I'm assuming that this is supposed to say hello. I'm assuming that's just a typo there. But anyway, what I'd like to do, rather than just going over this documentation that you can do on your own, is to kind of give you my take on things. So let's go into Unreal Editor, and we have a verse device and we have a button device, and the button is paired with the verse device. And the rest of this is in code. The way I define a parametric type is I would say a parametric types can take other data types as parameters. To me, that's the simplest way to understand it. And it might be helpful to think of parametric types as just generic type because they're based on the data type called type, which is the second most generic data type there is in verse. But then we also get into this terminology about explicit or implicit, and I found that difficult because those terms aren't yet defined in the glossary. How I interpret explicit to mean is clearer and more expressed, and that it applies to classes and functions, and then implicit is less clear and expressed, and it only applies to functions as argument. All this also leads to the question of, well, why do we even need to know about this? What are parametric types good for? They are good for creating functions and data structures that can accept any data type. So this means you could write a function once and use it all over the place because it's not tied to a specific data type. So it's good to use. It's very practical and has a lot of utility. The other thing is that parametric types, you're going to see them all over verse once you get into the API. And so they're just good to know. So there's a couple more things. Type is still evolving. The data type called type is still evolving. And so it does not yet support sub-expressions other than function declarations and where clauses. And if you only get one thing out of this tutorial, just know that wherever you see the keyword where, know that that's referring to an implicit type argument. And again, that word comes up, implicit. Well, what does that mean? Here we have this class that we've created called test class. Test class takes in any type of data and will have its data members initialized when called. So here you see we're assigning it type. And notice there's no use of the keyword where. It's directly assigned, right? It's clear that first item is type, second item is type, and that first item, which is the data type, is being assigned to item 1, and second item is being assigned to item 2. So item 1 and item 2 really represent the data type. This is explicit, I would say, because even though we don't know what the data type ultimately will be, we know the names of the data type and we know which position leads to what. We know that the first item we send in is going to be item 1, and we know the second item we send in is going to be item 2. And that's quite a bit to know, even though we don't know what the exact data type is. It could be an array, it could be a string, we don't know. But we do know it's going to be called item 1 and item 2, and we do know the position is going to matter. Whatever we send in first is going to be item 1, and whatever we send in second is going to be item 2. So that's very clear. It's more expressed, you could say. Now, if we come down here, we're also creating something called test function. And this is really kind of the star of the show, this whole test function. Test function basically is going to pass both arguments to test class, initialize them, and return them. And because val1 and val2 are generic types, or the data type called type, test function will accept any type of data. So here you'll see there is where we use the keyword where. Right away we know that this is an implicit typed argument. And here I just copied this top line of code right here just to show you the implicitness of it. because why is this implicit? Well, because it's not clearly defined or expressed. We don't know what the data is in. We don't know the names given to the type, and we don't know the position of anything. Type 1 is just a generic data type. That's all we know. We don't know anything. It doesn't have a name yet. Type 1 is not its name. It's just the data type. So we need to assign type 1 to something. And that's what we do up here, where we assign or initialize it, right? So we're going to get a data type in, and then we're going to assign it. But here, it's not explicitly tied to anything. It's just a generic data type, because what we do with this data type is still undefined. It's not clear. So this would be hard to read and code this because we don't know anything. We don't know what's in, we don't know what's out, and we don't even know the name of this data type. So this would be like the same as int or float or string. But this is just the data type called type. But instead of calling it type, we're calling it type 1. So anyway, back to this, we have our implicit arguments device, and we have an @editable for our button. And then on begin play, we just call this main function here. We also have this function called print string that takes in a string and puts out a string. All we're really doing is we're calling test function with different data types. So here we're calling it test function here. We're sending in 2 strings here. We're sending in an integer and a string here, a string and a float. And here we're actually sending in a function and an integer here. And I'm doing this just to show you that the range of things that can be sent in here. And then when this data is sent in, right, then we create this data type 1 and a data type called type 2 of type and assign that to item 1 and item 2, right? So whatever the data is that comes in, it gets assigned to item 1 and item 2, and it initializes our class, which we can then reference here. So when we call test function with the 2 strings, this D1 is our test class initialized. And then because it's returning 2 items, we can reference each item individually here. So we can go D1, which is a reference to test class, as initialized by test function with the 2 strings, and print out the value. And essentially, we're just going to get back what we sent here. And it's all the way down to a print string that we're setting, returning what was sent in our string, and we can even send that in and get that back as well. So that's all this really does. It just shows you that we can send any data type in, and then we can initialize these data members here with whatever we send in, and then we can reference that back out. So let's take a quick look at this in the code. If I come here and I go build verse code and push those changes, and then just take a look at this. So if I come in here, start the game, and I come over here to the button device, we're just essentially getting back what we send in. So when test function is called with 2 strings, item 1 holds a value of string 1, item 2 holds a value of string 2. When it's called with an integer and a string, we get 777 and string data 3. When it's called with a string and a float, we get string data 4 and the value of pi. And then the last one is returning what was sent, which is us actually sending in our print string function and getting the string value back. So anyway, that's all I had for today. I hope you found this helpful. Take care, have a great day, and I'll talk to you next time.